Hey guys, welcome to my recorded class for syntactic concepts in football. My goal right now is to sort of do a concise and digestible YouTube video on something like 15 minutes just on syntactic concepts. I want to try doing that. I think that doing online things in shorter time periods is easier to digest, basically. All right. So on Monday, we covered the syntax of this new language, FOPL, first order predicate logic. And the goal of this language is to introduce two new things into our truth functioning logic. So the two syntactic concepts we're introducing are existential quantification and universal quantification. Those are pretty big words, but they simply mean the two new types of well-formed formulas we're going to be dealing with now. So all the old familiar syntactic concepts like atomic, compound, conditional, biconditional, and subformula, all those still apply. We're just adding syntactic concepts. So we can still use these concepts from before to describe features in our language. All right, so the backwards E is the existential quantification. It more or less means some things. So it's specifying the meaning of variables which it quantifies over. And then the upside down A is universal quantification, and it specifies the meaning of variables as roughly all things in the domain. All right, so there's some other terms that are going to be important for talking about quantifiers. And I'm going to introduce these terms to you guys this YouTube video. The first term is quantify over. So I said that already, and now I'll explain what I meant. So for example, with a well-formed formula like f of x, x is a variable, to quantify over that well-formed formula right here, the red line under it, means to have a quantifier to the left of it. So this quantifier is quantifying over the variables in that well-formed formula. So another term that's going to be really important for describing the properties of quantifiers is scope. So the scope of a quantifier is the well-formed formula that the quantifier quantifies over. So quantifying over describes the variables. The scope describes the well-formed formula. So universal quantifier x here has the scope of this entire well-formed formula. And if you guys remember, on Monday, I made this analogy to the negation, the meaning of the negation, right? And how it interacts with brackets. So if a negation is on the inside of brackets, it negates the thing immediately to the right of it. However, if we draw the bracket here, ignore that one, it's negating the whole well-formed formula inside the brackets. Quantifiers work the same way when it comes to this, their scope. All right. So to add even more detail to quantifiers and scope, a variable that's not in the scope of any quantifier is said to be free. So it's a term applying to variables now, not just a property of quantifiers. So x here in this well-formed formula is free, And then if you add a quantifier quantifying over that x, it becomes bound. All right. And now here's a property of well-formed formulas. So any well-formed formula with a free variable is open. So here we have two variables, x and y, and neither of which have quantifiers quantifying over them. And I'll show you an example of closing this well-formed formula. So closing is when a well-formed formula has no free variables. I'm going to close this well-formed formula. And then closing the well-formed formula by adding quantifiers that quantify over these variables. This is a closed version of that same well-formed formula. And actually, I remember this from last year. This slide has an error in it that I have forgotten to remove. If anyone can guess the error before I say what it is, you're going to earn some points. Lecture points, made up points. All right. So that isn't actually a closed well-formed formula because it's missing a quantifier that's quantifying over y. We're going to add that. There we go. That is a closed well-formed formula now. Because the previous one was open, there was no quantifier quantifying over the variable y next to g. So just to reiterate, the new terms you just learned, two properties of well-formed formulas to do with variables are closed and open. Two properties of variables in those well-formed formulas are bound and free. So bound variables have a quantifier quantifying over them, and free variables do not. All right. So let's go through these guys and determine whether they're open or closed. So this is an exercise you guys are going to have to do yourselves. So this first one is open because there is no quantifier quantifying over x and y. If I wanted to close it, I would do this. Something like that. They could be any quantifier as long as it's, the universal or existential, the only two. This one is also open well-formed formula because quantifier x is not quantifying over y. It's still well-formed, it's just an open well-formed formula. All right, here's another open one. X and xy are missing quantifiers. I'm going to close it really quick. Existential x, existential y. All right, how about this one? This next one is closed for business. Just like South Carolina, hopefully, for the next month, and they don't reopen and let viruses infect us all. All right, how about this next one? Open. There's no quantifiers at all, even though there's variables. Here we go. Closed. And then here's a nice tricky one here. Is this open or closed? All right, those of you saying closed, you are right. And why is that? This is quantifying over the x's here. This is quantifying over the y here, and those are the only variables. The rest of those letters are constants, not variables. So A, B, constants in our language, or names. Right. So two quirks of FOPL that are different from TFL. You can have expressions that don't really make sense. So you can have nonsense like universal quantifier y hx. In other languages, maybe this wouldn't be allowed, but you're allowed to have a quantifier that doesn't quantify over anything, right? And when we discuss the semantics, you'll see why that doesn't make sense. But yeah, so it's still well formed, is what I'm trying to say. And also, variables existing without any quantifier also don't really make sense in terms of trying to discuss what they mean in like a model theoretic way. All right. And that is all I wanted to discuss in this YouTube video. So stay tuned tomorrow for FOPL semantics, and stay safe out there.